Hi and welcome back. As well as the datetime module, used to deal with objects containing both a date and time, we also have a date module and a separate time module. They're used to deal with dates and times separately. In this video, we're going to look at how to time your functions, how long they take to run, using the time module. So how is that going to go? Well, it's going to be really straightforward. Before we run the code that we want to time, we're going to look at the current time. After we run the code, we will also look at the current time, which will be a few seconds or a few milliseconds later. And then we'll subtract one from the other, and that's going to give us the difference between the current time at the start and the current time at the end, and that's going to tell us how long the code took to run. Why might that be useful? Sometimes you won't know whether to use a specific code or something else because you don't know which one's faster if they both do the same thing. For example, should you use list comprehensions or list and map? We're going to look at that in this video. Let's have a look at an example. The first thing we're going to do is import the time module. This has a bunch of functions that you can use to deal with times. And now we're going to come up with a function that we will time. We will look at how long it takes to run. It's going to be a simple function that is called powers and takes in a single argument, which is going to be a number, and then returns a simple list comprehension that does something like this. So it gives you a new list where x is in range limit, so it goes from 0 up to whatever number we give it, and each number is turned to the power of 2. And so just gives it a bit of calculation there. It's a pretty fast operation, it's really fast, but we can see how long it takes. Okay. Now, just to show you exactly how this works, we are going to print it out, just for you to know what it does. You can see here, it starts at 0, 0 to the power of 2 is 0, then it goes to 1, 1 to the power of 2 is 1, 2 to the power of 2 is 4, 3 to the power of 2 is 9, and so forth. Okay. Now, let's start by timing this function. The first thing to do is to get the current time before we run the function. So notice that up in here in line 6, we've not run the function yet, we've only defined it. So what we're going to do is we're going to say start is time.time. Time.time is, time module, and the time function within that module gives you the current time it gives you the current time since 1970. So it gives you the number of seconds that have passed since 1970, and that way you can look at essentially the current time. Now, it gives you it in seconds, but it also includes many decimal places to give you enough precision. So if this were to take only a couple of milliseconds or a couple of nanoseconds, you would still know. This is the current time at the start. Then we are going to do powers of, say, 50,000, 500,000, 500,000. Let's go 500,000. And then we are going to calculate the end time. And as you can see, it's exactly the same thing, but it's after the function has ran. So it gives us, essentially, this can take some time, and then we're going to look at the end time after that has happened. Because remember, these statements happen one after the other. And then we're going to do print end minus start. Remember, end is going to be the larger number. That's the number of seconds passed since 1970. Start is going to be the smaller number because it happened earlier on. So this is going to give us a positive number, which is the difference between end and start. That is the number of seconds or milliseconds that this function here took to run. Okay. And I'm noticing that my notes actually has one less 0, so let's just try it with one less 0 there, in case we're going to be waiting here for a long time. Yep, that was a good shout, I think. As you can see, it's taking a little while to give it a go, and there you have it, 6.79 seconds. So, that tells you how long this list comprehension took to run, as well as calling the function and so forth. It could be slightly, a few nanoseconds shorter if we didn't have a function, if we just did this in here. But you know, everything takes a little bit of time in Python and in any programming language, so that's just something that we have to deal with. Now, this is how you time your code, but of course, adding this start and end time before and after every piece of code you want to time can be a little bit cumbersome. So instead, we can turn it into a function. We can turn this stuff here, the measuring the start time and measuring the end time, into a sort of measure runtime function. That's what we're going to do in here. We're going to say measure runtime, and that is going to take another function that we want to measure. Okay. And at this, we're going to start by looking at the current time, then we're going to run the function, and then we're going to look at the end time, and then we're going to print end minus start. Okay. So basically, we're taking all of this, and it's the same thing that we had down here, except now it's a bit more generic because we can pass in any function we want. Okay. And the function we're going to pass it in now is we're going to say measure runtime of lambda powers 50,000, 500,000. 500,000 is correct. Okay, so we've defined a lambda function, and when you call this function, it will execute the powers function with a given number. Notice that we've had to do it this way, passing a lambda function. We can't just pass the powers function there, although that would be nice, because then we have no way of passing the argument that it needs. So the lambda function allows us to do that. It now creates a function that has no arguments, but calls another function that does have arguments. So it's just an easier way to do this here. And again, if we run that, we get this here. I think I may have missed, I think we had a 0 more before, that's why it took so much less time. But that's fine. If we add one more, it'll take the 6.7 seconds-ish, around 6 seconds. And there we go, 7.4. This is just depending on the load that is currently in REPL-it, how much power they can give our program compared to other people's programs that are also running at the same time. Okay. So, just as a small aside here, this measure runtime function is, of course, a decorator, or a higher order function. And the powers function here is a first class function, because we're passing it in, or we could pass it in as an argument. Okay. Now, if we just wanted to time the execution of small code snippets, we can look into a separate module, which is the timeIt module. Okay. So we're going to import timeIt down here, and I'm just going to decrease this 0 again so we don't have to wait too long. We've got the timeIt module, and the timeIt module has a timeIt function inside it, to which you can pass a string. And this string has to be a Python statement that you want to time. So for example, we can take this thing here. Instead of limit, we'll just pass 10, and then it will tell you how long this takes to run. So it can be quite useful as well. Now, if we run this here, you can see that it's not instant, right? It's still loading even though the range only goes up to 10. And that's because the timeIt function actually runs this many times over, and then it gives you the total it took to do many iterations. So it can be useful because you now have a statement here that will not take a very long time to run, but the timeIt module is telling you sort of an average or a total across many iterations how long it's going to take. And that's precisely because if you only run it once and you wanted to compare it against something else, say for example the timeIt of list map lambda x to the power of 2 range 10. There we go. Say you wanted to compare these two. If you were just comparing this statement to the range of 10 against this one to the range of 10, they're both going to take so little time, 0.00000 something seconds, that you're not really going to have a very good comparison there. So by comparing across many thousands of iterations, you do get a slightly nicer comparison. Let's run that again. By the way, remember this is quite slow because REPL-IT is not a very fast platform. It's not meant for performance, it's meant for functionality and letting you run this code on the cloud. So if you run this in your computer, it's probably going to be much faster. But we will see which one is better. And we're probably going to find that they're going to be more or less around the same. Maybe even map is going to be a little bit slower. Yeah, there you have it. Map's a little bit slower because you have to create the generator, you have to map over it, and then you have to turn everything into a list, whereas the list comprehension just creates you a list from the start. This does beg the question, which one to use? Should you not always use list comprehensions? They seem to be faster. And the answer is, if you want a list of things, use list comprehension. It's faster, I think it's more readable, it's certainly shorter, and there's no good reason why you shouldn't use it. But if you want to use the items of this list, these powers, one by one, then use map and use the generator it gives you. Don't turn it into a list. That way, you won't have to spend the time getting your full list in order. You can just use the items one by one as they are generated by the map function. So it just depends on how you're going to consume these things that you should decide which one to use. In addition, it's also a matter of readability. And as I said earlier, for me, the list comprehension is much more readable. So I would almost always go for that if given the choice. But some people prefer map because they're accustomed to doing that in other programming languages. So that's also a good reason to use maps instead of comprehensions. Anyway, that's it for this video. Just wanted to give you a quick rundown on how you can time your code and why you might want to do it. And hopefully this has been a nice experiment for you to look more into comprehensions and maps. So again, you can use a time module, calculate the starting and the end time for the thing you want to time. This can be useful in many scenarios and it's very flexible. Or if you want to time small snippets of code, you can use the time_it module, and that can be also quick and easy. That's it for this video, and I'll see you on the next one.